Hi guys, welcome back to my channel. So today we're going to be going over implicit differentiation. So what exactly is implicit differentiation? So we use implicit differentiation to differentiate or find the derivative of functions that do not have the relationship between the independent and dependent variable clearly expressed. For instance, normally we have an equation like y is equal to 2x squared plus 5. The relationship between x and y, that is the independent and the dependent variable, is clearly expressed in the sense that y is equal to 2x squared plus 5. That is, this is an explicit function. So if we differentiate this normally, what we're going to do is explicit differentiation because the relationship between x and y is clearly stated and expressed. When we have functions like 2xy plus 16x is equal to 20, this is an implicit function in the sense that the relationship between x and y is not clearly expressed in a y equals something something form. Rather, it is mixed up where you have x and y multiplying each other in this whole complex function. So we use implicit differentiation to deal with functions like this. While this is an explicit function, so you use normal differentiation for this. When you differentiate this first function, we'll have exactly 4x, since the derivative of any constant is 0. So do you understand? But for this, we use a different type of differentiation. It's still the same process, but how we go about it differs from how we go about this. So let's jump straight into it. We have a function x squared plus y squared is equal to 25. Find dy by dx. So how do we go about this? It's very simple. We just differentiate it the same way we differentiate a normal function. So the derivative of 2x is just going to... sorry, my book is unfolded by something. Sorry, my book was being disturbed. It was falling. Right, so we differentiate it normally. So the derivative of x squared, remember from your power rule, is just going to be 2x, right? Then you differentiate y squared. The derivative of 2y is just going to be 2y. Sorry, the derivative of y squared, is just going to be 2y. The derivative of x squared is going to be 2x. Remember from your power rule, 2 comes to the back, then minus 1 on top. So this is just going to be 2y, right? But because y is the dependent variable and it's changing with respect to x, you have to add the y by the x to it because y is changing with respect to x. This one is the same thing as 2x dx by dx, but because it's an x variable changing with respect to x, so the x by the x cancels. That's why we don't add it. But since this one is a y variable and it's changing with respect to another variable x, you have to add your dy by dx to it. So whenever you're differentiating any y function or any dependent variable, you must always add that dependent variable, the d by the dependent variable with respect to the variable you're differentiating with respect to. So, and the derivative of any constant is 0. So our answer is just going to be 2x plus 2y dy by dx is equal to 0. But this is now final answer, forgive me. So we have to factor out dy by dx. Remember, we're looking for dy by dx, the equation for dy by dx, the expression for dy by dx. This is not an expression for dy by dx. It's just like a composite, it's like a complex function that dy by dx is inside. So we have to solve for dy by dx. How do we do that? Just simple algebra. So 2y dy by dx is just going to be equal to take 2x to the other side minus 2x and divide both sides by 2y. So this cancels this. So 2 cancels 2. So dy by dx is in turn minus x over y. So let's take another example to, for the sake of practice. Alright, we have another function, x cubed plus y cubed is equal to 6xy. Find dy by dx. So it's still the same process, except we have, instead of a number here, we have another like function. So, and it's a composite function where we have x and y multiplying each other. So let's solve it. So if we differentiate x cubed, we're going to have 3x squared. Remember from the power rule. And if we differentiate y cubed, it's just going to be 3y squared. But remember, since it's the dependent variable, we have to add dy by dx to it. Remember. So for this one, we have to use the product rule because we know we have 6xy, so they are multiplying each other. So let's use a quick route. So you hold one of them constant and differentiate the other one. So let's hold x constant first. That's going to be 6x. Then differentiate y. If you differentiate y, you're just going to have 1. But remember, you have to add dy by dx to it. So times 1 dy by dx. So plus now let's hold x constant, or rather 6x constant. Sorry, let's hold y constant and differentiate 6x. So we differentiate 6x with respect to x. It's just going to be 6 then y. Remember, we're holding y constant, so that's just going to be the answer. So 3x squared plus 3y squared dy by dx is equal to 6x dy by dx plus 6y. I hope you understand. For this one, we use the product through 6xy. Remember, if you have two functions multiplying, use the product through that formula, u dv by dx plus v du by dx, that formula. So let's take 6x as one function, let's take y as one function, another function. So let's hold 6x constant. That's what is basically here, u constant, then differentiate y, then plus we'll hold y constant and differentiate 6x. So if we hold 6x constant, differentiate y, the derivative of y is just going to be 1. But since it is the dependent variable, we have to add your dy by dx. That's why we have 6x dy by dx here. Then plus hold y constant now. Since we already held 6x constant in this first one, we'll now hold y constant in this second one. So y is constant, then we'll differentiate 6x. That's just going to give us 6. That's, remember, we're differentiating with respect to x. So derivative of 6x is just going to give us 6. That's why we have 6 right here. So our equation now becomes 3x squared plus 3y squared dy by dx is equal to 6x dy by dx plus 6y. So the last thing we need to do, we need to factor out dy by dx. So let's take 6x to the other side and take 3x to the other side. So we have 3y squared dy by dx minus 6x dy by dx is equal to 6y minus 3x squared. Sorry, my 6 looks very ugly. Yeah, so let's factor out dy by dx. So we have dy by dx, factor dy by dx out, then open bracket, 3y squared minus 6x is equal to 6y minus 3x squared. So what we need to do now is just divide both sides by 3y squared minus 6x to get dy by dx. So divide both sides by 3y squared minus 6x divided by 3y squared minus 6x. So this cancels this. So our dy by dx is equal to 6y minus 3x squared over 3y squared minus 6x. Please pardon my handwriting, I have a very bad handwriting. Alright, so let's take the last question. We have e to the xy is equal to x squared plus 8y. So we have to find dy by dx. So it's the same old process, but here we have an exponential function, and we have x and y multiplying each other. So we have to use the product rule for this one. Then we'll differentiate this one normally. So let's go. So if we have e to the x, remember if you have a function e to the f of x, the derivative of this function is just going to be f prime of x multiplied by e to the f of x. That means you just differentiate what's on top, then multiplied by the original function. For instance, e to the 2x. So if you differentiate 2x, you're just going to have 2. So the answer is just going to be 2 times e to the 2x. That's how I differentiate any exponential function. So let's handle this one. So but we have an x times y, we have xy here, so we have to use the product rule. So we're going to have let's first hold x constant, then differentiate y. So that's just going to be e to the x y multiplied by the derivative of y, holding x constant, that's going to be x dy by dx. So then plus, now we'll hold y constant and differentiate x, so that's going to be y times the derivative of x, that's just going to be 1, then times e to the xy, then it's equal to this. Let's write this out first. Let's not differentiate it yet. X squared plus 8y. So we'll have e to the xy multiplied by x dy by dx plus y times 1 is just y times e to the xy. Now let's differentiate these two. So the derivative of 2x squared is going to be 2x, and the derivative of 8y with respect to x is going to be 8. Then remember, because it's a y, that's the dependent variable, you have to add your dy by dx. So now let's factor out let's bring our dy by dx together. We factor out that when we bring our dy dx together, we have this one, then minus this comes here, then take this to the other side. Now we factor out dy by dx and divide both sides by that coefficient. So we have something like this. So now let me just rewrite this. This is going to be dy by dx, open bracket, x e to the xy. It's the same thing. Minus 8 is equal to 2x minus y e to the xy. So now let's divide both sides by xe to the xy minus 8. So xe to the xy minus 8 divided by xe to the xy minus 8. So this cancels this. So divide by the x is equal to 2x minus y e to the xy divided by x e to the xy minus 8. So that's how you implicitly differentiate this function. So let's take an economic application. This is question. So we have an isoquant function 16k raised to the power 1 over 4 L raised to the power 3 over 4 is equal to 2144. So an isoquant is basically a graph or a function that expresses the various combinations of two inputs, usually label and capital, that produce the same amount of output, in this case 2144 units. So the question says use implicit differentiation to find the slope of the isoquant, and that's basically decay by L. That's basically how much capital changes with respect to labor. That's also known as the marginal rate of technical substitution. Basically, how many units of capital you have to employ with respect to a change in units of labor. Basically, how capital changes with respect to labor. Forgive me for using basically too many times. So in the second part says evaluate the MRTS, that's the marginal technical substitution, at k equals 256 and L equals 108. So for the first part, they're just asking you to differentiate the function. Then the second part, they're saying the value, that differentiated function, just plug in k equals 256 and L equals 108 to it. So let's go into the first part. So we have 16k raised by 1 over 4, L raised by 3 over 4 is equal to 2144. So we have to differentiate this implicitly with respect to L. So L is our independent variable. So these are two functions multiplying each other, 16k raised by 1 over 4 and 16L raised by 3 over 4. So we have to use the product rule. So let's first hold k constant and differentiate with respect to L. So we have 16k raised to the power 1 over 4. Then we differentiate L with respect to L. That's just going to be times 3 over 4 L raised to the power 3 over 4 minus 1 is just minus 1 over 4. Then plus, now we hold L constant and differentiate k. So remember, k is our dependent variable. So whenever I differentiate k, you must add the k by the L to it. Don't forget. So now we have 1 over 4 comes to the back. Then times 16. Then k raised to the power 1 over 4 minus 1 is just going to be minus 3 over 4. The k by the L, then multiplied by what we held constant as L raised by 3 over 4. L raised by 3 over 4. Please forgive me, I have kids around me. Then the derivative of any constant with respect to any variable is just 0. So let's simplify this whole function. So 4 in 4 is 1. 4 in 16 is just 4. Then 4 times this 3 here is going to give us 12. So we have 12k raised to the power 1 over 4 times L raised to the power minus 1 over 4. Then plus 4 in 4, 1. 4 in 16 is still 4. So we have 4k raised to the power minus 3 over 4. So let's bring L to the front. So times L raised to the power 3 over 4. Then the k by the L is equal to 0. So let's write out the function again. So we have 12k raised to the power 1 over 4 times L raised to the power minus 1 over 4. Then plus 4k raised to the power minus 3 over 4 times L raised to the power 3 over 4. The k by the L is equal to 0. So now remember, we're looking for the k by the L. So let's factor it out. So let's take this bad boy to the other side. So we have 4k raised to the power minus 3 over 4. L raised to the power 3 over 4. The k by the L is equal to, remember, taking this to the other side, minus 12k raised to the power 1 over 4 times L raised to the power minus 1 over 4. So we need to eliminate whatever is associated with decay by the L. In this case, 4k raised to the power minus 3 over 4 times L raised to the power 3 over 4. So let's divide both sides by that. So we have 4k raised to the power minus 3 over 4 L raised to the power 3 over 4 is equal to, then divide this to 4k raised to the power minus 3 over 4 L raised to the power 3 over 4. So this cancels this. So the k by the L is going to equal 4 in 4, 1. 4 in minus 12, that's minus 3. So we have minus 3k raised to the power 1 over 4 L raised to the power minus 1 over 4 divided by k raised to the power minus 3 over 4 L raised to the power 3 over 4. Yeah. So let's now simplify this. So I have this function. So let's simplify it. So remember that let's just, so the k by the L is just going to be minus 3k raised to the power 1 over 4 times L raised to the power minus 1 over 4 then divided by k raised to the power minus 3 over 4 L raised to the power 3 over 4. So yeah, so now let's simplify this. Remember, if we want to convert division to multiplication, whatever is up comes down. So and this changes to multiplication. So this is going to equal minus 3k raised to the power 1 over 4 L raised to the minus 1 over 4, then multiplied by 1 over k raised to the power minus 3 over 4 L raised to the power 3 over 4. So now we can rewrite this function. So we can have this to be minus 3k raised to the power 1 over 4 L raised to the power minus 1 over 4 multiplied by 1 over k raised to the power minus 3 over 4 multiplied by 1 over L raised to the power 3 over 4. So now let's further simplify. So this gives us equal to minus 3k raised to the power 1 over 4 L raised to the power minus 1 over 4. So remember, any the inverse of any function is the same thing as that function raised to the power minus 1. So if we raise this to the power of minus 1, let's just write it. So we have k raised to the power minus 3 over 4 all raised to the power minus 1. And the same thing for this. L raised to the power 3 over 4 all raised to the power minus 1. So our function now equals minus 3k raised to the power 1 over 4 L raised to the power minus 1 over 4. So minus 1 times this, remember from your laws of indices, just going to give us times k raised to the power 3 over 4. Then times minus 1 times this, it's just going to give us L raised to the power minus 3 over 4 from your laws of indices. So now let's simplify. So we have minus 3k raised to the power 1 over 4 here, and k raised to the power 3 over 4 here. So when they multiply, we have minus 3k raised to the power 1 over 4 times k raised to the power 3 over 4, then multiplied by L raised to the power 1 over 4, what we have here, then times L raised to the power minus 3 over 4. So when this simplify, 1 over 4 plus 3 over 4 is going to give us 1. So we have minus 3k raised to the power 1. Then multiplied by minus 1 over 4 minus 3 over 4 is going to give us minus 1. So L is equal to minus 1. So our decay by the L is just going to give us minus 3k times L raised to the power minus 1. And L raised to the power minus 1 can be written as 1 over L. So this is equal to 3 times minus 3k over L. So our decay by the L is just going to give us minus 3k over L. So we've solved the first part. Then it says evaluate decay by the L where k equals 256 and L is equal to 108. So just plug in those values into this place and we'll have our answer. So decay by the L is just going to give us minus 3 open bracket 256 divided by 108. So you can just plug this into your calculator and get your final answer. Let's just put the answer. So decay by the L is equal to minus 7.11. So this is our marginal rate of technical substitution. Basically tells us by how many units we should increase or decrease capital with respect to any 1 unit increase or decrease in labor. So if we increase capital, if we increase labor by 1 unit, increase labor, remember if I say if we increase labor by 1 unit, we have to decrease capital by minus 7.11 units. And if we decrease labor by 1 unit, we have to increase capital by 7.11 units. So that's basically the relationship. So any decrease in labor will cause for an increase in capital by plus 7.11, and any increase in labor will cause a decrease in capital by minus 7.11 units. So that's basically the interpretation of this.